Finish out number 2. We use the product of powers here. That's the property we use to to evaluate that. Now let's look at this one. Now the first property we're going to use power of a quotient. Okay, and so what's going to end up happening here is we're going to end up with -2, okay, to the third. Then we're going to have a2 times 3 b3 over a5 times 3 b3. Now I'm just writing in the exponents that are actually there. Remember, there's not an exponent, it's the same as 1. Okay, then we're going to use power of a product. Okay, so this is where we're going to actually multiply the exponents together, so we end up with -2 to the third, a to the 6th, b to the third, over a to the 15th, b to the third. Okay, now we're going to use power of power, which is where we went through and did all that. Now, and then finally we're going to use quotient. Alright, now when we do this, we're going to end up subtracting the exponents. Okay, -2 to the third power. I'm going to go ahead and deal with that. -2 to the third power is going to give us 8. Okay, because it's -2 times -2, which would be +4, times -2 gives us -8. Okay, and then just to go through the process, it's be a to the 6 minus 15. Okay, then b to the 3 minus 3. So we ended up subtracting these. Now, alright, so here's what we have. We have -8, a to the 9th, b to the 0. Well, that's going to end up being 1. Oh, I'm sorry, and that's negative. So b is 0, so b to the 0 power gives us 1. So we end up with -8, a to the -9. Now we're going to use the negative exponent and put it underneath to get it positive. So we end up with -8, a to the 9th. Now I went through a long way to get here. Now you could shorten the process, and that's fine. I just wanted to show through all the steps. Alright, in this we're looking at our beach ball. The radius of the beach ball is 5.6 times greater than the radius of a baseball. How many times as great as the baseball volume is the beach's ball volume? Let R represent the radius of the baseball. Alright, so let's go through this. So beach ball's volume. Now the volume here, we're going to have to put in R's 5.6 R, because that's our radius of the beach ball. Okay, now the formulas could be given on your formula sheet, but the volume of a sphere is 4/3 power cubed. Okay, and so we know that the radius is 5.6 R. Okay, so now we're going to use our power of products rule here. If you notice, the 4/3 and the pi's will cancel out, and then so we'll end up with 5.6 to the third power R to the third power. Okay, now from this we have R to the third divided by R to the third, so that's actually going to be R to the 0 because we end up subtracting the exponent. So we end up with 5.6 cubed over, I'm sorry, not over, 5.6, because everything canceled out with that. We end up with this. So we're just going to take 5.6 to the third power, remembering that this ends up being 1. 5.6 to the third power is going to be roughly 176. So the beach ball's volume is about 176 times as great as the baseball's volume. Alright, for this one, what we're going to do is rework the same problem, but this time it's 6 times instead of 5.6. So remember that for the volume is 4/3 pi okay, r cubed. Okay, and so this we're going to substitute in as 6r. Okay, now that's all going to be over the volume. Okay, now, so this is our radius that we're cubing. We don't know dimensions, so that's why we're leaving r and no dimensions. So we're going to cube this, so we end up with, well, let's go ahead and cancel these out. Those cancel out. And then we end up with 6 to the third, r to the third, over r third. Okay, so these will cancel out, or be left with 6 third r to 0, which is 1. So we end up with 6 cubed. Now 6 cubed is going to be 216. So it's basically 216 times as great. Alright, now what I want you to do now is you're going to go ahead and work through the practice problems that are associated with this lesson, so that in order for you to retake it. I'll put them on in just a second. Alright, here's 1 through 20. Now again, this matches up to your note-taking guide. So if you have your note-taking guide, you don't need this. I would go ahead and pause this because I'm going to move on to the next questions. These I'm actually going to work out the first two for you just to make sure that you've seen problems like this. Alright, now if I'm writing this in scientific notation, my decimal places here, I'm counting places as I go back, and I stop so that I have one number in front. We're going to keep everything that's not a 0, so it'll be 5.27 times 10. Now we went back 1, 2, 3, 4, 5, so it'd be to the 5th power. Now if you notice for 22, it's really, so this would be a bigger number, this is a smaller number. We count back doing the same thing, so we go 1, 2, 3, 4, 5. We want one number in front, so it'd be 5.26 times 10. Now since we went to the right, we put negative 5. Alright, so I want you to try the rest of these. Alright, here's 27 through 40. And again, this matches up to your note-taking guide, lesson 4.1. Okay, then here's problems 41 and 42. Once you've completed this, the note-taking guide on this section, you can retest or reassess on standard MM2a2a. If you have any questions, you can ask during class, or I'll be happy to answer your questions.